Good day, my wonderful viewers. Once again, you're welcome to Chris Feco Education. As you can see, we are still on the modular arithmetic. Previously, we just talked about the division and multiplication of modular arithmetic. Now, we shall be looking at modular tables of addition, subtraction, and multiplication. Now, at first, we are starting with the addition. Now, if you watch here, you will see that this is the table for the addition, and this addition table is in mode 4. Now, in order for us to fill in this table, we have to make sure that every of the figures that we are putting in this table do not exceed 4. Now, we are going to do some of the problems in this space that is provided for us. Now, let us look at the addition table. Now, in this addition table, this is the space for addition. In this addition table, we have 0 plus 0 will give us 0 here. 0 plus 1 will give us 1. 0 plus 2 will give us 2. 0 plus 3 will give us 3. Now, all these things are written in their pattern. Why? Because they are no more than 4. Now, let us take the one of the 1. 1 plus 0 is 1. Our normal arithmetic. 1 plus 1 is 2. 2 is no more than 4, so we'll put 2 here. 1 plus 2 is 3. 3 is no more than 4, we'll put 3 here. So we'll say 1 plus 3 here is 4. We have 4 here. 4 cannot repeat itself. So we'll say 4 divided by 4 will give us 1 remainder 0. So this remainder, which is 0, we put it here. So we'll come to 2. 2 plus 0 is 2. 2 plus 1 is 3. 3 is not more than 4. 2 plus 2 is 4. We say 4 divided by 4, we have 1 remainder 0. So we'll put what? 0 here. We say 2 plus 3 is 5. We have 5. We divide by the mode, which is what? 4. So 5 divided by 4 will give us 1 remainder 1. So here should be 1. We have 3 plus 0 is 3. 3 plus 1 is 4. We divide by 4. We have 1 remainder 0. Here is 0. 3 plus 2 is 5. We have 5 divided by 4, which is 1 remainder 1. Here is 1. Now 3 plus 3 is 6. We have 6 divided by 4, which will give us 1 remainder 2. So we'll put 2 here. Remainder 2, we put 2 here. Now the other one is the subtraction table. Now this subtraction table also is in mode 4. Now we say 1 minus 1 will give us 0. Are you seeing it? 1 minus 1 will give us 0. 1 minus 2. Look at it. 1 minus 2 will give us minus 1. 1 minus 2 will give us minus 1. So if we have this minus 1, there is no how we can put this minus 1 here. And also we should remember that this is in mode 4. So we can either say, okay, minus 4, which is the mode 4, minus 4 plus 3 is the same thing as minus 1. So minus 4 plus 3 is equivalent to what? Minus 1. Or you can just say 4 minus 1, which gives us a positive inverse of what? Of 3. So we'll come here, we'll put 3 here. So that is 1 minus 2. Here will give us what? 3 for the subtraction. Now 1 minus 3 will give us minus 2. Coming, let us take it one after the other. We say 1 minus 3. 1 minus 3 will give us minus 2. Now this is minus 2. We can also say IA, because of is in mode 4, we'll say 4 minus 2. 4 minus 2 will give us 2. Or you can say minus 4 plus 2. Minus 4 plus 2 will give us minus 2. So the positive inverse is what? Is 2. We put 2 here. That is for the negative. Now also we consider the case of the 2. So we have here 2. 2 minus 1. 2 minus 1 is 1. 2 minus 2 is 0. 2 minus 3 will give us, look at it, 2 minus 3 will give us minus 1. Remember I said since it's in mode 4, we say 4 minus 1, which is 3. Or we can just say that that minus 4 plus 3 is the same thing as minus 1. So we'll take the positive inverse. So here should be 3. So we'll have the case of the 3. 3 minus 1 will give us 2. 2 is below 4. 3 minus 2. 3 minus 2 will give us 1. 3 minus 3 will give us 0. This is the table for the subtraction. Now we'll come to the multiplication table. Now in the multiplication table, we have our normal multiplication process. Just like here, we'll have 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, 1 times 4 is 4. Now we have here 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. We have 6 here. 6 is more than 5. We have 6 divided by 5, which will give us 1 remainder 1. We'll put 1 here, which is the remainder. We'll take the remainder and put it here. Then we'll have the next one, which is 2 times 4. 2 times 4 will give us 8. 2 times 4 is 8. We'll say 8 divided by 5. 8 divided by 5 will give us 1 remainder 3. 1 remainder 3. So what do? We'll take the remainder, which is 3, we'll put it here. 1 remainder 3. So we'll have the next one as 3. Have the next one as 3. We'll say here 3 times 1. 3 times 1. 3 times 1 is 3. 3 times 2 is 6. We say 6 divided by 5, which gives us 1 remainder 1. We have 1 here. We say 3 times 3 is 9. 9 divided by 5 will give us 1 remainder 4. We have 4 here. 3 times 4 is 12. We say 12 divided by 5 will give us 2 remainder 2. We have 2 here. So that is for the part of the 3. So now we'll have the case of the 4. 4 times 1 is 4. 4 times 2 is 8. Because of its in mode 5, we say 8 divided by 5, which gives us 1 remainder 3. We have 3 here. 4 times 3 is 12. We say 12 divided by 5 will give us 2 remainder 2. We have 2 here. We have 4 times 4 is 16. We say 16 divided by 5, which gives us 3 remainder 1. We have 1 here. This is it for the multiplication table of mode 5. So in this pattern and ways are the possible avenue in which we can solve problem on the multiplication, addition and subtraction tables on modular arithmetic. So if you look here, here is the activity. You can try this on your own and see how far you can go in completing this table. The first question here is on addition table, where we have the 1, 2, 3, 4, 1, 2, 3, 4, and is in mode 5. Here is also the subtraction table, where we have the 0, 1, 2, 0, 1, 2. This is a subtraction table and is in mode 3. We also have the multiplication table, which is in mode 7 of 5, 6, 7, then 4, 5, 6. So we are expected to arrange this table in such a way that it will correspond with the patterns of the mode. Thank you for viewing to this channel.